Next, we're going to see some trends that exist within the group. We saw general trends the last time. We got to see that on the periodic table, as you move across the period, metallic properties decrease. As you move down the group in a metallic group, metallic properties increase. As you move down the group in a non-metal group, metallic properties decrease. These are the general trends we talked about the last time. Okay, as you move across the period, metallic properties decrease in a group. In a metallic group, as you move down, the metallic properties will increase. In a non-metals group, as you move down, the metallic properties will decrease. Now, today we're seeing some trends in specific groups. And then the first specific group we're talking about is group 1. Melting point is the temperature at which a given solid will change from the solid to liquid, or it will start to melt. Now, as we move down the group from lithium to francium, melting point decreases. Melting point decreases. So if you want to heat lithium to a liquid, the temperature will be at 175 degrees Celsius. Whereas for francium, you only need about 25 degrees Celsius to heat francium to change it to a liquid. Okay. The reason is because for lithium, it only has 2 shells. 1 and then 2. Okay. So the force of attraction between the nucleus and the valence electron is very high due to the short distance. The force of attraction between the nucleus and the valence electron is high. Now, when you take, let's say, potassium, the nucleus is in the middle. We're going to have 2 electrons here. Then we have 8. Okay, we have 8 electrons. Then we add another shell that is filled with a further 8 electrons, giving us 18. So 1, 2, 3, 4, 5, 6, 7, 8. We're still not done. We will need one more shell to complete the electronic configuration of potassium. And here are the 19 electrons of potassium. Now, if you look at the distance between the nucleus and the valence shell, it is very, very long. It is very, very long. So the force of attraction between the nucleus and the valence shell will be weaker than the force of attraction between the nucleus and the valence shell in lithium. And this means that less amount of energy will be needed to break this force. Less amount of energy will be needed to break this force. Hence, the reason for the low boiling point or the low melting point as you move down the group.